In April 2019, a radio signal was detected which had come from outer space. The source of it looked to have been in the region of Proxima Centauri, some 4.26 light years away from Earth. Alpha Centauri, Latinized from a Centauri and often abbreviated Alpha Cen, is a triple star system in the constellation of Centaurus, consisting of 3 stars: Alpha Centauri A, Alpha Centauri B, and Alpha Centauri C. Alpha Centauri A is a little bigger than our Sun, and Alpha Centauri B being smaller, so our Sun fits exactly right between the pair. The Centauri region is older than our Sun, with an age of 5 billion years. But where among the stars did this signal come from? And from what exactly? The signal received was heard from a scientific research program, one of the largest, called Breakthrough Listen, aimed at finding evidence of civilizations beyond Earth. The scope and power of the search are on an unprecedented scale. The program includes a survey of 1 million closest stars to Earth, scanning the entire center of our galaxy and the entire galactic plane. Beyond the Milky Way, it listens for messages from the 100 closest galaxies to our own. An estimated $100 million has financed the project, along with thousands of hours of telescope observations. The signal was detected by the CSIRO Parkes Radio Telescope in New South Wales, Australia. While the telescope was observing the region nearest star to our Sun, Proxima Centauri, it almost went undetected among the large volumes of data collected over the time of the thousands of hours. However, the astronomers discovered it like a needle in a haystack. For the signal to be considered, it would need to have 2 definitive traits. First, it has to be limited to a small band of frequencies, just like radio. And as these signals are unusual and there's no natural mechanism in space that can create such a signal. The second property, it should consist of a frequency that would fluctuate according to the analogous motion of the exoplanet that's relative to Earth. The astronomers had to go through nearly 4 million individual signals. The signals picked up by the Australian telescope. After much sifting and discarding of unnecessary signals, they were able to find 5,000 distinct signals, and among them was the chosen one, a single signal which could not be explained. After multiple cross-checks with contemporary radio transmitters on Earth, it was truly one of a kind Techno signature, with a narrow broad band that came only when the telescope was pointing towards Proxima Centauri. It appeared over a 30-hour observation period, and on deep diving the derived location, turned out to be Proxima b, discovered by the astronomers in 2016 by using the radial velocity method when a star doesn't remain stationary, when it's being orbited by planets due to the gravitational pull from the small planets. The star will move in a small little circle, extremely sensitive. Spectrographs are used while researchers track the planet's starlight spectrum. The star's light appears a little blue. It's shifted when there is a planet around it, and a little red. It shifts when it moves away from the planet, and when these shifts are repeated after a fixed number of days, months and years, and at regular intervals, then it is accepted that the shifting of light is definitely caused by the to and fro tugging by a planetary body orbiting around the star. Upon closer inspection, Proxima b turns out to be identical to Earth. The exoplanet seems to have a radius of 1 to 1, Earth, and mass of 1.3 times that of our planet. With an equivalent density, it is a rocky world. There are differences too. First is the location of these 2 planets. In their solar system, Proxima b is much closer to its parent star, located only 0.05 astronomical units away. Even Mercury is at a distance of 0.0 for astronomical units, making Proxima b closer to its star. With such distance, the planet should be fiery hell, just like Mercury. But Proxima Centauri is a faint red dwarf, and just like Earth, it receives 60% of its energy, and therefore making the planet's orbits in the habitable zone, and this means life could potentially exist there. There are countless numbers of unknown planets scattered across our universe, which we have already discovered, and an astonishing 4,935 exoplanets. Recently we came across 65 new planets that have taken our tally to 5,000. The latest batch of 65 exoplanets were added to the NASA Exoplanet Archive. The James Webb Space Telescope is 100 times more powerful than its predecessor. With its help, we can unravel the secrets of the boundless expanse. In the past that we have discovered all kinds of planets, small rocky worlds, gas giants larger than Jupiter, and extremely hot inhabitable planets. Out of all of these, there are a few that stand out. Kepler 1649c is one such planet. Its characteristics are very similar to Earth. In fact, it is the most habitable planet that we have discovered that may shelter life. Till now, we've been able to find 55 of these Earth-like planets, but not yet been able to study all with the rate at which our technology is advancing. Because of the James Webb, who knows what we may be capable of in the future? And wouldn't it be amazing to come across a planet that could sustain life? And technically, it's one of the James Webb Space Telescope's primary goals. During its first year of science missions, was to find and study extraterrestrial worlds beyond our solar system, with a focus on how they form, as well as the possibility of them obtaining water and biological life. The Webb's research into star and planet formations allows us to link studies of mature exoplanets to their birth conditions, as well as our own solar systems to its origins. The James Webb infrared capable abilities are perfect for revealing how stars and planets are formed for three particular reasons. Infrared light penetrates dust, takes up the thermal signatures of young stars and planets, and indicates the presence of key chemical constituents like water and organic chemistry. Mid-infrared lights may pass through clouds. They are 20 times thicker than visible light. This is especially important when looking at newborn stars that are concealed inside their natal clouds. As the clouds haven't dispersed for these young stars yet, we can't see visible light. The James Webb infrared capabilities are crucial because they allow us to see and investigate and grasp the early stages of star formations, when the gas and dust are still squeezing inwards to give birth to young stars. There's much more to natal star clouds. The young stars and giant planets both start off as huge puffy structures. They gradually contract over time, while newborn stars become hotter. As they grow older, the giant planets become colder, but they both emit more light in the infrared than the visible wavelengths. This means the Webb will excel at finding new stars and planets. The James Webb will aid in our understanding of the physics of the formation. MIRI will also look for heated molecular gas near numerous young stars, which could indicate the formation of rocky, potential habitable planets. Astronomers will be able to reach an agreement on the concentration of bulk molecules, including the beginnings of ice, at the very earliest phases of planet formation, thanks to these such observations. It's no wonder that a large portion of Webb's early scientific work focuses on determining how planetary systems construct molecules that may be crucial for the advent of life as we know it. On the 22nd of November 2022, NASA's James Webb Space Telescope scored yet another first: molecular and chemical profile of a distant world sky. While Webb and other space telescopes, including NASA's Hubble and Spitzer, previously have revealed isolated ingredients of this broiling planet's atmosphere, the new readings from Webb provide a full menu of atoms, molecules, and even signs of active chemistry and clouds. This new latest data gives a hint of how these clouds might look up close, broken up rather than a single, uniform blanket over the planet. The future of the James Webb Space Telescope is super exciting. In planetary terms, planets are sculpted and transformed by orbiting within the radiation bath of their host star. On Earth, those transformations allow life to thrive. NASA are going to get to see a bigger picture of the exoplanet atmospheres. Incredibly exciting to know that everything is going to be rewritten.